Hello friends, today we are just going to complete our remaining exercise, that is 2.1. Okay, in the earlier last lecture we have completed till the question number 6. So let's start with the question number 7. In that we have the two different numbers and we have to choose that which is the smaller and which is the larger. And we have to say that which number is on the number line situated on the left hand side. Okay, so let's start how we will do. First of all, there is 530 and 503. So just observe the numbers and just identify that which is the smaller, which is the greater, or you can just identify that on the number line. Which number comes first. Suppose if I just draw the number line, let's just draw like this. Okay, here we have the number line, and here that is the whole number. It means we have to just start with 0. Okay, and if suppose we are just doing for the natural number at the time, we will start with 1 only, because natural number don't consist 0. Okay, so here for the whole number we will just start with 0. Now after 0 there is 1, 2, 3, 4, 5 like that. Okay, till 100, 200, 300, 400, 500. Let's start with the 500 now. Suppose 500, then 501, 502, 503, 504, okay, and again so on. Okay, till the plus infinite, okay. And this is the number line, how we can just represent for the whole numbers. Now this line, it means it connects to 5 and 500. Okay, after 5 there is 6, 7, 8, 9, 10, and again from like 400, 401, 402, all the numbers are there in between this. But we have the limitations of the board. That's why we are just going to just showing by the symbols of the days. Okay, so it means it makes it continuous from 5 to 500. Now one more thing which you have to see, that just identify these two numbers. There is 530 and 503. Which number comes first? Let's see. 500, 501, 502, 503. So the first number comes, that is 503. After that 504, 505, like 520, 525, 26, 527, 528, 529 and 530. So here we can say that 503, the number 503 is on the left hand side to 530 on number line, or if I just want to show by the symbol, I can just write that here is 503 and the first number is 530. So let's write first 530 and the 503. Okay, how which sign we will represent? Mainly to compare the numbers, we have total the three signs. The first one is greater than, less than, and the equal one. Okay, fine. This is the greater sign, this is the less than sign, and this is the equal one. Here the sign, it means, suppose, first of all just say one example. Suppose if I just write 5 and 7, 5 and 7, just identify these two numbers, which is the bigger one. 7 is the bigger one. Okay, now from this sign just identify which side is the bigger. This one is the bigger one. Okay, and here this one is the bigger one. So we have to select the sign, okay, according to the bigger number. Here is 7, which is the bigger one. Okay, now identify the bigger side to the sign which is situated on right hand side, because 7 is on right hand side. That's this one. Okay, and this sign is left. Okay, that is the less than sign. Fine, this is the less than sign. Now one more example, like 17 and 15. Okay, now again see here, which is the greater one? This one is the greater one. It means we have to put the greater one on this side. So here I will write like this. Okay, and that sign is the greater one. How we can speak for this? Let's start with the 5. Here see, 5 is less than 7. 5 is less than 7, and here 17 is greater than 15. 17 is greater than 15. This is how we can pronounce, or how we can just speak in the statement form for the symbolic one. Now one more example, like 5 and 5. 5 and 5. Here both the numbers are equal. It means that is really simple. Just put the equal sign. Clear? This is how we can denote with the sign. Now here 530 and 503. Which is the bigger one? Of course 530, that is the bigger one, because 503, that is actually comes first on the number line. So we can say that the numbers which comes first on the number line, they all are smaller in compared to other numbers. Other numbers, it means which numbers comes after that number. Like 530 comes after 503. That's why 503 is smaller than 530, or 530 is greater than 503. In both these we can speak. Fine. Now again, I just have to put the sign over there. Just identify that which is the bigger one. Oh, this is the bigger number. Okay. Now I have just put the bigger side, give the bigger side to 530. So we can say that 530 is greater than 503. Now just observe here is 370 and 307. Now which number comes first on the number line? Now we can just give the answer properly, that which is the smaller number, 307. It means on the number line 307 comes first in compared with 370. Fine. So this one is the smaller one. Now how we will put the sign? Here is 370 and here is 307. Okay. Now I just have to put the sign. Just identify that which number is the bigger one. 370, that is the bigger one. So just give the symbol according to that. Here I will mark greater sign. Okay. So here we can say that 370 is greater than 307. This is how we can just do the questions of any comparing numbers. Okay, like 1 lakh or 2 lakh, if you are comparing, then 1 lakh is the smaller one, the 2 lakh is the bigger one. So for any number, process is always same. Now just pause the video and note it down. Now the question number 8. In the question number 8, the different statements are given, okay, and we have to just check that the given statement is correct or not. So let's start with the first one, that is A. Okay, that is 0 is the smallest natural number. 0 is smallest natural number. Okay, now before we do, just identify that natural number starts from which number? That is actually starts from 1, like 1, 2, 3, 4, 5. It means there is no 0 in the natural number. So can we say that 0 is the smallest natural number? No, because 0 is not the natural number. So we cannot say that it's the smallest one. Okay, to become the smallest one, the first condition is it should be the natural number. But here the 0 is not the natural number. That's why the given statement that is wrong. Okay, it's not the correct one. Fine. Now the second one. 0 is the smallest whole number. Now again, just identify that the whole number starts with which number. Actually that starts from 0, 1, 2, 3 like that. Okay, so the smallest one. Okay, smallest one, it means which number comes first. That is the smallest one. For the natural number, we can identify that the smallest number, that is 1, because it starts from 1. So 1, 2, 3. Okay, so same thing here in the whole number. Just identify that whole number starts with which number? That is 0. So yes, here we can say that 0 is smallest whole number. Okay, so here the given statement that is correct one. Now the C one, the third one, that is 0 is the smallest. Oh, sorry, that by mistake I just did. This is the 0 is the smallest whole number. That's the third one. The second one is remain. Okay. Okay. Earlier we just did the 0 is the whole number. That was the third one, C1. Now the B1, that is 400 is the predecessor of 399. Okay, we have to check that 400 that is predecessor of 399. Predecessor means the numbers which comes first, okay, before the number. So here we have to check that the number 400, that is the predecessor of 399. Okay, now to identify that is the predecessor of 399 or not, how we will check that? We will just subtract by 1. Here I will just subtract by 1. Now 9 minus 1, that is 8. 9 as it is, and 3. So here we can see that 398 is the predecessor of 399, not the 400. It means the B1 is wrong. Fine. Now C, which we have already did earlier. Now the D, that is 600 is the successor of 599. Now okay, here the D1 we have to do for 599. We have to identify that which number is the successor for 599. So to find the successor, we will add plus 1. So here 9 and 1, 10, 0, 1, 9 and 1, 10, 0, 1, 5 and 1, 6. So here we can see that the 600, that is the successor of 599. Okay. So the given statement, that is the correct one. So here we can say that the given statement is correct. Okay. Now the next, that is E. All natural numbers are whole numbers. All natural numbers, it means, first of all, just identify that the natural numbers, it means 1, 2, 3, 4, like this. Okay. And whole number, it means this is the set of the natural number, and here I am just going to write the set of the whole number. Whole number, it means 0, 1, 2, 3, 4, like that. Okay. Now the statement is all the natural numbers are whole number. So here, see, it's 1, 2, 3, 4. Here is 1, 2, 3, 4. It means till plus infinite, and here as well as till plus infinite. So here we can say that natural numbers are whole numbers. So yes, the E1 is the correct one. Now the F, that is all whole numbers are natural numbers. All whole numbers are natural numbers. Now see here, all whole numbers, it means 0, 1, 2, 3, 4, all the numbers are natural numbers. Yes, from 1 I can say, but 0 is not there in the natural number. So we cannot say that all the whole numbers are natural numbers, but we can say that all the numbers, all the whole numbers except 0 are natural numbers, but we cannot say that all the whole numbers are natural numbers. So the F1, that is wrong. Okay, now just pause the video and note it down. Now the next question, that is G. It says that the predecessor of two-digit number is never a single-digit number. Okay. So predecessor of two-digit number, that is never the single-digit number. Predecessor means the numbers which comes first, which comes before the next number. So for example, the predecessor of 3, that is 2. Okay. Okay. And the question, that is the predecessor of two-digit number, that is never the single-digit number. Let's check that. Suppose I just select the 22, then the predecessor, that is 21. Now suppose I select the 30, then predecessor is 29. Okay. So in the first view we can say that, okay, that's the correct. Okay, that's the correct. But now identify the smallest two-digit number, that is 10. That is 10. And for 10 we can identify that the predecessor of 10, that is 9. That is 9. So here we found that. Here we found that there is one number, that is 10, okay, which is the two-digit number and having the predecessor of the one digit. So here the given statement is wrong. Given statement, that is wrong. Fine. Now the H1, that is 1 is smallest whole number. 1 is the smallest whole number. So first of all, just list down the whole numbers from the starting one. So that is 0, 1, 2, 3 and 4, like that. Okay. Now just identify that which is the smallest number, that is 0. But in the statements they said that 1 is the smallest whole number. So again the given statement is wrong. Given statement, that is wrong. Now the next, that is I. The natural number 1 has no predecessor. The natural number 1 has no predecessor. First of all, let's find the predecessor of 1. Predecessor of 1, it means 1 minus 1, that is 0. Okay. Okay, that is 0. So here we can say that 0 is the predecessor of 1. But the question is, the natural number 1 has no predecessor. The natural number 1 has no predecessor. It means it should be natural only. So here the one having 0 as a predecessor, but 0 is the whole number. We have to find for the natural number only. So it means the given statement, that is wrong. Okay. For any natural number 1 have not any predecessor. Fine. Now the J1, that is the whole number 1 has no predecessor. The whole number 1 has no predecessor. So again, just identify here. Now here is the whole number 1. Suppose this is the whole number 1. Now 1 minus 1 is 0, and that is again the whole number. It means whole number 1 having the predecessor, that is whole number 0. So again this given statement is wrong. The actual correct statement, that is yes, the whole number 1 having the predecessor. Fine. The next one, that is K. Okay, the K1, that is the whole number 13 lies between 11 and 12. 11 and 12. Okay, 11 and 12. Now from the number line we can identify that if we just find the numbers from the 0. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and then 13. Now the statement says that the 13 lies between 11 and 12. But no, actually 13 comes after 12. It means given statement that is wrong. Then after K, that is L, the whole number 0 has no predecessor. The whole number 0 has no predecessor. Let's check. 0 minus 1. Okay. So that is not possible because the answer will be minus 1. Okay. Answer will be minus 1. You will learn that how to do this in the grade 7. But right now just understand that 0 minus 1 that is not possible actually. Okay. So it means 0 do not have the statement is 0 has no predecessor. Okay. That's the correct one. Okay. That's the correct one. 0 has no predecessor. Now the last one, that's the M. That is the successor of 2-digit number is always the 2-digit number. Successor of 2-digit number. So let's check that. 19. Okay. Successor of 19. Successor it means we will just add by 1. We will plus 1. It means the next number. So 19 then 20. We have to check that. The successor of 2-digit number cannot be 3-digit number. So let's see, like 55, that will be 56. Okay, so here we can identify that for all the numbers, all the 2-digit numbers, successor is 2-digit number only. But just identify the largest one, largest 2-digit number, that is 99. And after 99, that is 100. So we can say that here there is a one number that is 99, which is 2-digit number, and it's having the successor as a 3-digit number. So given statement is wrong. Okay. So here we have completed exercise 2.1. Now just pause the video and note it down. Today we are going to discuss about the properties of the different numbers. As we know, the different type of numbers are natural numbers, integers, whole numbers, and the last one which we did, that is the rational numbers. For all that, today we will try to understand the different properties for that. So here we are starting with the natural numbers and the operations on the natural numbers. These are the mathematical operations as we learned. So that is addition, subtraction, multiplication and division. Mainly they are different properties, but right now we are just going to discuss about these three properties: closure, commutative and associative. Now question arises that what is closure, what is commutative and what is associative? Closure it means, suppose if you are doing for the natural number and for the addition, if I say, if I do the 2 plus 3, if I select any two numbers from the natural numbers and I do 2 plus 3, for example, if I do 2 plus 3, answer will be 5. Answer will be 5. Now your result should be from the same type of number. Should be from the same type of the number. It means if I am doing subtraction for the addition, I am getting the answer from the same type of the number. But for the subtraction, let's see what will happen. If I do 2 minus 3, plus minus, it means 3 minus 2, that is 1. But the sign of the bigger number which we have to put here, the bigger number is 3. It means we need to put the negative sign over there. So that's minus 1. Now just try to understand that. Can we say minus 1 is natural number? No. Here 2 is natural number, 3 is natural number. But minus 1 is not natural number. It means subtraction is not closer, and it is not closer for the natural number. So this is what we will do in all these type of properties. Let's start with the closure. So here in the closure, addition is closure. Yes, here we did. So yes, that is. Now for the subtraction, it's not closure. It means I will put for no cross sign, and for yes I will put the right mark. Okay. Now for the multiplication, let's see. We have to select any two natural numbers like 5 and 3. 5 into 3, that is 15. So 15 is Yes, that is from the natural number. So multiplication, yes, that is closer. For the division, let's see, if I do 6 divided by 2. So here, what we will get? 2 3s are 6, 0. It means answer is 3. But suppose I am just taking a number like 15 divided by 2. So 2 7s are 14. 2 7s are 14 and 1. So now what we will do? We will put the decimal point over there and put a 1 0. 2 5s are 10. Answer is 0. This is the decimal number. Can we include decimal number in natural number? No. It means this is also not the closer one. Clear? Now for the commutative. What is commutative? Let's understand first. Suppose I am taking any two number from the natural number set, that is 2 and 3. So 2 plus 3 I am doing for the addition. Okay. 2 plus 3 is 5. 2 plus 3 is 5. Now, what I have to do? I have to shuffle this number. I have to just shuffle this number. Like 3 plus 2. 3 plus 2. Answer is 5. If we get the same answer, it means addition is closer under commutative for the natural number. Addition is closer under commutative property for the natural number. So it means here addition, here that's yes, it is. Now for the next subtraction, let's check. Taking the same numbers, 2 minus 3. 2 minus 3 is minus 1 and 3 minus 2 is 1. It means no, because both these numbers are different. It means no, it is not commutative under the subtraction. Then multiplication. Let's see, 2 multiplied by 3, that is 6, and 3 multiplied by 2, that is again 6. So yes, multiplication is commutative. So here, yes. Now division. Again, if I do 6 divided by 2, answer will be 3, like this. 6 divided by 2. So 2 3s are 6 and 0, that is 3. But if I do 2 divided by 6, what we need to do? First of all, we need to take 0 and then point, and we will put here. So 6 3s are 18. It means whatever I will do, answer are different. So it's not. Now for the associative. Let's understand what is the associative property. Okay, and first of all I am doing for the addition. So in the associative, I have to select any three numbers from the same type of numbers. Here we are doing for the natural numbers. So we will select the three natural numbers like 2 plus 3 plus 4. 2 plus 3 plus 4. Here I have to make a group for any two number. I am just making the group for this first two. So it means I have to first of all solve the bracket. 2 plus 3 is 5. 2 plus 3 is 5 and 4 as it is. So answer which we got, that is 9. That is 9. Now next time I have to do same thing only, but with the same number only, okay. But I have to change the group. So I just changed that group, and now this 2 as it is, because in mathematics always we have to solve bracket first. So here 3 plus 4 is 7 and 2 plus 7 is 9. So if after the changing the groups, if you get the same result, same answer, it means the given property, which property we are doing, associative, is, sorry, the natural number is closed under associative for the addition. That is closed under associative for the addition. So here that's the result. It means for the addition it is yes. For addition it is yes. Now for the subtraction. So let's see what will happen. Of course that's not, but see, like 2 minus 3 minus 4. I am selecting always the same number so you can understand properly. 2 minus 3, that is minus 1. Minus 4 as it is, that's minus 5. Okay. Now I am just changing the groups. Like 2 minus 3 minus 4. Okay. So here this is 2 minus 3 minus 4 is minus 1. Minus minus plus, it means 2 plus 1. Answer is 3. Both the number are different. It means no, it is not associative for the subtraction. For the subtraction. Now we will do for the multiplication. Okay, in multiplication again, what we will do? We will select the same types of the numbers from the set given, that is natural number. So again I am going to select 2 multiplied by 3 multiplied by 4. Here is the bracket. So what I will do? 2 multiplied by 3 4 are 12 and 12 2 are, that is 24. That is 24. Now again in the next one I need to change the groups. So 2 multiplied by 3 multiplied by 4. So 2 3s are 6. 6 multiplied by 4. That is 24. This both the results are same. It means yes. Associative multiplication, that is associative. Now for the division, for the associative, I am going to choose the different type of numbers, not 2 3 5, because that can be more convenient to find out that division is associative associative for the natural numbers or not. So I am going to take 12 divided by 6 divided by 2. Okay, I am making this group first. So is equals to 6 divided by 12 divided by 6, that is 2, divided by 2 is equals to 1. Now I am going to change the group. So that will be 12 divided by 6 divided by 2. For this I can say 12 as it is, divided by sign, that is as it is. And again here 6 divided by 2, that is 3. That is 3. 12 divided by 3, that is 4. See, these both are different. It means natural number is not associative under division. Under division, it is not. Okay, clear? Now one more thing. For the natural number and as well as for whole number, W, these properties are same. These properties are same because there is no difference. Only one single difference, that is in whole number we just add 0 and in natural numbers we are not using 0. Okay, fine. So for this both, these properties are same. So note it down for the whole number as well as natural number. Okay, pause the video and note it down.